everybody, hope you're having a great day. I recorded this phone call with my dad that I thought you would think is interesting because it's a question that I get asked all the time on the phone, and it's also a question that I see online quite a bit as well. So hopefully this will be good information for you if this ever happens at your house. You'll know what is going on and how to prevent it as well. So here is my little chat with my dad today.
Wherever you need to. It doesn't feel cool or that sort of thing.
Yeah,
so,
I think that the most commonly asked question online, two-parter, where is water coming from in my air conditioner? Like they see water and they're like, why is this happening? How could water, where's the water coming from? And it's leaking out of my air conditioning unit. And then also how does ice form on the air conditioner?
Right.
These are what is
and
confounding.
The ice is forming when things aren't working well either. So.
Exactly.
Yeah. You've answered the phone for a lot of years and you probably have dealt with that a lot.
Mm-hmm. Yeah. So why do you, how do you explain, I know what I say on the phone to people if there's water leaking out of their furnace or if their air conditioner is frozen over. Basically, my strategy is to say, shut it off so that it melts, and then the technician will come out and take a look because there's clearly a problem. Right. That's the extent of my knowledge. So what, as a technician, do you talk about?
The whole water thing happens on the indoor coil of the air conditioner. It's actually called the evaporator coil, but it's the indoor cooling coil. We usually just call them a cooling coil so people, don't get hung up in technical things. But basically, when an air conditioner is operating normally, that coil inside, we are gathering all the air up inside the house and we blow it across this coil. And this coil that's where the magic of refrigeration happens. We actually take the heat out of the air going across that coil. But when we take the heat out, we also take not all the moisture, but we take a good part of the moisture out of the air as well. Because that coil, when it's operating properly, is cold. It's physically cold. And if you think of in the summertime with the humidity levels that Kansas City summers are like, if you just imagine like when you're sitting out on the deck with a cold drink, a glass of iced tea, you've got that cold glass outside, and what happens when you set that cold glass outside?
Right. It starts to sweat.
It starts to sweat and ends up in a little puddle or something, Well, that's what's happening on that evaporator coil, that cooling coil inside. It's cold, and we're taking air out of the house, gathering it up, blowing it across that coil, and it's cold, so it condenses moisture out of the air and has to run off, to a drain properly, that sort of thing. So it's like a gigantic dehumidifier. A good part of the cooling that your air conditioner does is it's also dehumidifying the air as well. And so when we take that moisture out of the air, it feels more pleasant. It takes that mugginess out of the room, that sort of thing. So, the lack of humidity in the house in the summertime is just as comfortable as the cooler temperature. If it's just not as humid as what it was. So, but so you mentioned the icing up. Okay, well, there's a strange phenomenon that happens that when an air conditioner can malfunction in a number of different ways. It could be a refrigerant charge is not proper. It could be a problem with airflow not being right. But we can have a time where that evaporator coil, that indoor cooling coil, operates too cold. It actually operates below freezing, below 30 degrees. When it does that moisture that we're taking out of the air, that humidity that we're taking out of the air, freezes to the coil. So it literally turns into a block of ice.
Oh, okay.
And so when it ices up, how much air do you think we're going to be able to pass through it?
Right. None.
It's a block. Which compounds the problem even more, because one of the problems is airflow, and so.
But why would it be like, I'm assuming that it's not supposed to be below freezing.
It's not supposed to be.
So why does it do that?
Because if we have a refrigerant charge that isn't quite right, that usually just slightly short of refrigerant, it can actually cool and function and operate. However, that coil can actually operate at just right at freezing or a little below freezing. So it's still refrigerating. It still has the capability of freezing something, this moisture, but it's actually malfunctioning. Once it starts doing that, though, it turns into a block of ice and shuts off the airflow. So you've probably heard me before saying, people will call in and say, gee, my air conditioner, it's not cooling. My house is hot. I can hear it running. I can hear it. It sounds like, the unit outside in the yard, it's running and everything. And many times I'll ask them, if you go to a register, do you feel any airflow? And sometimes the answer is no, I don't. Well, that tells me that it's probably iced up. Now, why it's iced up, I don't know yet. But that's why we say, well, let's just turn it off until the man gets here, and we'll go from there.
And so you said that it could be a bad refrigerant charge. That's what, like during routine maintenance and stuff, when the technicians talk about putting their gauges on, that's what they're checking for, correct?
Right. That's
to make sure that that's not going to happen.
Exactly.
Okay.
Exactly.
Now,
you can have an air conditioner that is properly charged and operate it with a really restricted filter of some kind or something like that. And that lack of airflow across that evaporator coil can also make it operate too cold and freeze the moisture on it and turn into a block of ice. So
a super caked up filter can cause the same effect. Same
effect. And until you thaw things out and start the air conditioner up and observe it operating, you really don't know which, and it's like so many things when it comes to an air conditioner. We've got this symptom, but it can have multiple causes. The multiple things can make it ice up,
So then what would cause, like, let's say your air conditioner was fine last summer and this summer it ices up and it's due to the refrigerant charge being off. How did that change?
That changed because something leaked. That refrigerant leaked out.
Okay.
If you've got a system that has no leaks on it, the refrigerant itself doesn't go bad, get stale, wear out, lose its effectiveness,
It's supposed to be a closed system, right? Where it's all just
It's a closed system, right. And as long as we don't have any leaks, you should be okay. I've had some customers say, I just want it recharged. And then, as you visit with them a little bit, you find out that they've been recharging this every year. Well, guess what? It's leaking out,
Right.
So, and if that's the case, it's leaking as we're talking right now. As soon as the guy packs up his truck and leaves, it's leaking right now. And so it's only a matter of time that it affects the efficiency. And it's going to basically have the same problem all over again.
Yeah, it's not like a tank of gas where you just fill her up and the problem's solved.
Yeah, or think about that analogy. I've got a gas tank leaking, and what I do is really the way to fix that is just fill it up every day, or fill it up once a week.
Yeah.
And it doesn't seem to be a problem. So, now with refrigerants have become so expensive.
Oh, it's crazy.
Depending on what refrigerant we're working with, but gosh, it's not a quick, easy little the cheapest thing you can do is just put more refrigerant in it. It's that is not the case anymore. So
right. Okay, cool. Anything else you think would be valid on that topic on water? Any other water issues? You would see it from the coil on the indoor unit, probably, right? Or ice would be on the outside, or is ice also on the inside?
Well, so far, no, water is a huge issue. I know Matt was training the guys just the other day on nothing but water because now we've just been talking about where water comes from, and it's basically the humidity out of the air. But oh no, it's a whole nother subject as far as getting it from your air conditioner to the drain in your basement. It's like, we got a drain pan that goes with that evaporator coil, that cooling coil, that we want to keep it clean and unrestricted. In the ductwork, if you think of it this way, that cooling coil is inside your ductwork down in the basement, and it's dark in there, okay? And it's also cool, and it's wet. We're dealing with this weather. So think about that one. Darkness, coolness, and wetness. What does that sound like to you? And so
MOLD?
It turns into slimy stuff.
Yeah.
Whether it's mold or not, it turns into slimy stuff. And so that's where we now will put a pan treatment. We will treat that water that's sitting in that pan. And oh my gosh, you cannot believe how many fewer calls. That makes sense that I use the proper word, but it has helped immensely. We see the difference immediately, as far as having water problems, having a plugged up little drain hose or a drain line or a drain pan. But we treat that with an algicide, so we can go through a full season and know that it's not going to turn into gunky stuff and not drain properly.
I see.
And so keeping the water where it's not supposed to be, that's quite a challenge at times, so I had a previous house. I had the guy who poured the concrete floor in my basement. You've got your floor drain right there next to the air conditioner, right? The furnace and air conditioner downstairs. There's the floor drain, but if any water got outside that little 6-inch circle of the floor drain, the water would run towards the carpeted rec room. It's like the floor wasn't level, so it's like, you'd like to think if there's ever water on this floor, it's going to flow to the drain. Well,
flowing opposite.
In my house, that was not the case.
Right.
That wasn't the case. So we want to be very careful in getting it, keep it away from things that can be damaged, things that you want to keep dry. You've got to be very conscious of that air conditioner drain.
So I've also heard of sometimes it can't there be condensation, not condensation, condensation in your ductwork?
It can, and not in the ductwork, but usually on the ductwork.
Like
so
around
think
it?
about it. Just like that example of the iced tea glass. So your ductwork that goes through your basement or goes through your garage or something like that, that ductwork, when the air conditioner is on and cooling, is cold. The metal ductwork is cold. And so if warm, moist air comes in contact with the outside of the ductwork, it's going to condense moisture just like that iced tea glass. And so you can have issues in basements, where extremely humid down there that you can actually get moisture on the outside of the ductwork.
Does that create any problems, or is it just kind of annoying? So how do you solve that?
We installed dehumidifiers. And, I have one at my house, and oh my gosh, what a difference it makes. Yeah, and everybody, I've got a big finished portion of the basement, but then I have a rather large storage area. And, you could always feel it, on the floor. If you're barefooted on the floor, you can feel the floor is kind of cool, and it's not wet, but you can feel there's moisture in the concrete. You can just feel it, And, oh my gosh, I put in a dehumidifier in that part of the house, and oh my gosh, what a difference. Just, you can tell the feel of the room. It is not humid. Right. And the thing is moisture in a home knows no boundaries. So if your basement storage room is humid, it's getting out into the rest of the house, and conversely, if you dry that air out, you're really drying out the whole house.
Mm-hmm.
And so that's a great accessory item is a whole house dehumidifier. They are extremely efficient in how they operate. They do a phenomenal job as far as the amount of moisture they can take out of the air. And you can actually keep your house a few degrees warmer and be just as comfortable when you're keeping that humidity.
So you don't need to run the AC quite as hard if you have the humidifier. Because without the dehumidifier, you're relying on the air conditioner to do all of the dehumidifying itself.
Exactly.
So if you help it out a little bit, it's glad.
Or let's say it's a time of year that big dehumidifier we're talking about is operating whenever your thermostat says, hey, the temperature is getting too warm. Well, what if we're in a time of year that it's not really super hot out, so that air conditioner really isn't running that much, but the humidity is there, but it is humid out. You know, that big dehumidifier that we call your central air conditioner really isn't doing any good at all. You know, where this whole house dehumidifier, we'll duct it right into the ductwork sometime. Other times not. We'll just duct it into the basement. And so think of a cool, clammy basement. If we dry it out and actually warm it up a few degrees because of the operation of the dehumidifier, it feels so much better.
Right.
But it's operating independent of the air conditioner, so we're not cooling the house down more than what we normally would.
Right. It kind of it helps keep a more even temperature, and and then just helps with the whole condensation. Why can't I say that? Condensation. Not
condescending.
Not condescending.
Condensation.
Condensation problem. Okay. All right. Well, that's good.
Condensation.
Yeah. Okay. So a blocked kind of airflow can create ice and water, whether that be because the filter is all blocked up or because the refrigerant charge is not quite right. And
without getting too technical, even on a cooler day, if the outdoor ambient is a little cool on the cool side, you can create a condition where we could be a little too cold. You know, at evaporator coil, a little too cold. But that's not as residentially. That's not as big a deal. Whereas in some commercial buildings, it is. You know, there are many times where we need the air conditioner running when it's actually kind of cool outside. And so that
reminds me, Dad, sometimes I can't remember, but if it's 100 degrees outside in the middle of August and somebody has their thermostat set to like 65, could that create a problem because you're trying to keep it like a refrigerator in your house, or no? I've never really understood that.
It shouldn't create a problem.
Okay.
However, it's an expectation that isn't necessarily going to be achieved, you know. So
it's just not going to happen.
So if you think of it, is it a problem if I tell my air conditioner to run nonstop? Yeah. Well, you could create a problem, you know. But
I thought that there might have been some kind of random issue one time that I remember taking a phone call on where somebody was trying to keep their AC was icing up, I thought, but they were also they wanted their house to be like 62 degrees, and it was the middle of summer, and I was wondering if that in itself created a problem. But you're saying
yes, it did.
Oh, okay.
And yeah, I've seen it all. We've had customers that want to keep their house. I mean, I'll call it frigidly cold. I mean, so cold that it's like, how can you be comfortable with this, you know? But you are operating well outside the normal design conditions of what most central air conditioners are designed for, you know? And so we can create problems. Just like the time the guy had a garage full of chocolate candy and cookies.
Oh no. Trying to keep his garage.
The little kids that the little kids that sell candy,
Yeah.
Well, he operated a business where that's what he did. He had kids selling candy
Out of the garage.
Yeah, out of his garage. He wanted to keep his garage, so he wanted to store all of his candy and cookies out in his garage.
Well,
but
it's not impossible, isn't it? If you install like a huge air conditioner that might be for a restaurant or something. I mean, you could do that.
It's but that wasn't the case. He had his regular house air conditioner. I'm trying to use my garage for cold storage, so it's not going to work.
Not going to work.
Not going to work.
All right.
Yeah.
Cool. Well, thanks. I think that answered the question. It's a very common one, so hopefully that helps people.
Mm-hmm.
All right. Thanks, Dan.
Very good.
Talk to you later.
See ya.
Bye.